In this module, we're going to start with some very simple models, and then I'm going to introduce what we mean by Monte Carlo simulation. And we'll start with a very simple model. Say here in this spreadsheet, I have elasticity of demand as an example, right? Now, if we assume that the elasticity of demand will be constant, that is, the effect on demand for a unit price increase is going to be same at all levels of price. And if under that assumption, the demand to price relationship would be something like this: demand equal to a constant b sub 0 times price to the power of the elasticity coefficient b sub 1. We don't know what b sub 0 and b sub 1 will be, and that's something that we have to analyze with the model and see what uncertainties are inherent in the estimation of b sub 0 and b sub 1. But to set the model up and to get started, let us assume a number for constant, say 1000, and for elasticity minus 1.2. Okay. And these two are uncertain variables. So let's do some color coding here. Like that. Now, unit cost is a variable that we know what it is. It is deterministic. It's an input value. So let's assume it's $10. Okay. So let's format it to dollar format, and we'll use a different color system for constant or deterministic values. And then we have the pricing model that we want to use, okay, with this constant elasticity of demand assumption. So now we want to determine at what price we will maximize profit if the demand elasticity is of this type. Okay, so price is what we have to decide on. So this is a decision variable, and let's use a different color system for decision variable. Okay, and we will not have any color background for formulas, calculated values. So we need to follow a color coding scheme to make the spreadsheet and the model more readable. Okay. So now using the constant elasticity function, then we can find the demand, which will be constant times price to the power of the elasticity. Okay. So that's going to be our demand. And for the moment, let's not worry about this not being a whole number. And if we needed that to be a whole number, we can always use a round function. Okay. So now what is the profit? Then profit will be price minus unit cost. That will be the profit per unit. And then we multiply by the demand. Okay, so that's giving us the profit. So now what we want to do is, if this constant elasticity of demand is correct, then what will be the profit mainly, and I've included demand as well, at various price levels. Okay, so we want to do some sensitivity analysis. Okay, so we can use DataTable for that. So we have DataTable is a feature in Excel, and we can set up all the different price levels at which we want to see what the profit will be. So let's say we start with $25. Okay, let's change it to currency format. And then let's say that we want to increment it in $15 increments. Okay, and we want to go all the way till 175. Okay, so we'll go one more. Okay. Now these are the different price levels for which we want to analyze, or we want to look at what the profit will be. Or is there a price level at which we maximize profit? So in which case that will be the profit. So as you increase the price from 25 on, and the profit keeps going up, but after a certain price level, because of the decline in demand, your total profit starts to decline. So the profit peaks at a particular point, and that would be the maximum profit price. If it does, sometimes it may not. It may monotonically keep on increasing, which probably is because some problem with the assumptions, because that's not the practical situation that we know. So if something counterfactual occurs, then we know that there is some problem in the model. Okay, so we want to look at the demand. So demand is here. Okay, and then profit is here. Okay, so we need to set up a template like this for the data table to work. So we have prices in the first column. Okay, and then in the next column onwards, at the top, just one row above the first price, we have all the outputs we want to see. So here we want to see two outputs. So we have one for demand and one for profit. Okay. So now we can do this the other way around too. So you can put the prices along the columns in one row, and then the demand and profit this way. So you can transpose this if you want, but this format looks all right. So now once you have set up the template, then we have to apply the data table. So before we apply the data table, we have to highlight the table like this, okay, with the first column consisting of all the different price levels that you want to input into the model, and then the first row of the table containing the outputs that you want to see. Okay, then you go data table. Okay. Now this data table has only one input, which is the price. Everything else is output. Okay, so the data table can have just one single input, or it can have two inputs. So if you have two inputs, then you will have to enter cell addresses for both of them. If you have only one input, then you only input one input cell address. And that cell address is where should the input values go. And then, if the input values are arranged in a row like that, then it will be a row input cell. But if the input values are arranged in a column like how we have arranged, then it is a column input cell, not a row input cell. Okay. So row input cell, we will leave it blank. So column input cell, okay, where should the price go into the model? In the model, price is in B11. So B11 is what we select for column input cell. Okay. So now we click OK. The data table is going to take each price and insert it into this input cell, and then it'll output demand here and profit here. Okay. So there we have the output, and see it inserts an array function called table, and it populates the entire table. And this table is an array function, which means if you want to change something, then you have to go back and highlight the entire table and do the changes. You cannot just change one cell. Like if I try to delete one cell, it's going to give me an error says you can't change part of a data table. Okay, so let me format this. Okay, and I want to make this into currency format. Okay, and as you can see, profit increases and then it starts to decline after this point. And we can plot this to see how it looks in a graph. Say we want to plot like that, right? So you insert and we select a plot. Then you want to change the plot parameters. So instead of the x-axis being just 0 through 12, we can insert price there by selecting select data. So this is the series that it is plotting. So edit that. Okay, and the x values are these. Okay. Now we can change the title. So this will be profit versus price. Right. And then you use this plus sign to include, if you like, x-axis and y-axis titles. Okay, so the x-axis is price and y-axis is profit. Okay, and then you see that somewhere around here is where the profit peaks, and that would be your optimal price. And of course, that depends upon our assumption that two assumptions we're making. One is the elasticity of demand would be constant, which means that this is the function that defines demand with respect to price. And then the second assumption is the parameters of the demand function b sub 0 and b sub 1.